In this video, we will discuss about Introduction to Engineering Mechanics. We cannot learn engineering just by reading books. We have to look at physical systems, as well as natural systems around us, and ask questions such as why and how these are made the way they are. Let's imagine driving a bike on a wet road. As the force of friction, which holds the bike, will be low on wet roads, we may fall down. So, it is better, if we study mechanical interactions between different bodies, and effect of forces acting on them, so that we can avoid such mishaps. We have seen the failure of many structures like bridges, rockets, machines, because of engineering failures that happened majorly due to neglecting forces acting on them. We can learn so much from failure than success. If we can thoroughly understand all the forces acting on a system, we can create engineering wonders. Burj Khalifa, in UAE, is the tallest living structure, till now. From its foundation to its structural components, and mechanical systems. The design and operation of the tower is based on the fundamentals of engineering mechanics. Mechanics is the science which describes and predicts the condition of rest or motion of bodies, under the action of forces. The principles of mechanics are also applicable to machines. It may be a simple machine such as a bicycle or a machine as complex as an aircraft. When mechanics is applied in engineering, such as design of machines and analysis of mechanisms, is called engineering mechanics. It consists of the mechanics of rigid bodies, mechanics of deformable bodies, and mechanics of fluids. In this subject we are mostly concerned with the mechanics of rigid bodies. Let's see what is a rigid body first. Rigid body. A body is formally regarded as rigid, if the distance between any set of 2 points in it is always constant in time regardless of external forces exerted on it. This basically means that you can't deform it by any means. It's somewhat an indestructible thing. The closest thing to a rigid body might be diamond, carbon nanotubes or its derivatives. In real life all materials can be deformed, that is non-rigid. Physical bodies deform slightly under the action of loads. Calling a body rigid means that the changes in the dimensions of the body are small enough to be neglected. By idealizing a body as rigid, simplifies dynamics calculations. One such case is finding trajectory of a body. If we idealize it as a rigid body, we can track a point on it, preferably the center of mass, and can find its trajectory easily. It is much harder to do the same thing for a non-rigid body, because they deform much more. So in short, rigid body approximation is pretty helpful and is well understood in mechanics. It solves most troublesome problems with ease. The mechanics of rigid bodies is subdivided into 2 groups. When different bodies interact through the forces applied on each other, there are 2 possibilities. They may remain static or they may move. Statics and dynamics.